Okay, here we have a question about energy. So figure 1 shows a battery-operated remote control car. The car's battery contains a store of energy. So as it's a battery, it must be chemical energy. As the car moves, energy from one store is transferred into another store. Describe how the different energy stores change as the car moves. So we know it starts with chemical energy. So the store of chemical energy decreases. And that's because we're using it. That is then becoming kinetic energy as it moves, and because there's an electric motor, that will then convert the chemical energy to kinetic energy, but you also lose some as heat. So we could then say that energy is less usefully stored. The chemical energy is a useful store, but the thermal energy of the motor, that's still a store of energy, but it's not useful for us. Here you need to remember that energy cannot be created or destroyed, it goes from one store to another store. So, the car has a top speed of 12 meters per second and a mass of 800 grams. Write down the equation that links kinetic energy, mass and speed. This is one that you needed to remember. So you've got kinetic energy equals half times mass times speed or velocity squared. I'm using speed here because it says it in the question. So you have quite a lot of equations you need to memorise. One way is to use flashcards. You have what the parts are on the front and then the link equation at the back, or have the equations written down on post-it notes and stick them around your house. Calculate the maximum kinetic energy. Okay, so we now need to use this equation. So we do half times our mass, which is 800 grams. Of course we don't use grams, so that needs to be 0.8 kilograms. 0.8 times our speed was 12. We just need to remember we were squaring it. That will give us a maximum kinetic energy of 57.6 joules. Explain why having a more efficient motor would increase the top speed. So again, 2 marks, there's 2 key points. Well, if it is more efficient, then less energy is wasted. So all that efficiency means that we've got more of the input energy goes for useful, so we have less waste. That would mean we'd have more energy that could become kinetic energy. So if we increase the efficiency, if less energy is being wasted, then more can be converted to useful kinetic energy. Okay. Figure 2 shows an electric car being charged. A driver wishes to buy a new car. The table below gives some data about an electric car and a petrol engine car. So this is analysing data you've been given. Which car would be the most economical for 12 years? So you've got the initial cost of each one, the price per year, and how long it will last. So they'll last the same, so we don't need to worry about that. But the running cost and their cost per year are different. What I would do is work out how much this would cost per year. So for the electric, it costs 27,000 in total. if we try to work out a price that would be per year, that would give us £2,250 per year. If we then add how much it costs to run per year, you've got £2,250, add £250 for the running cost, which give £2,500 per year. Then do the same for our petrol car. So it costs 15,000, and divide that by 12 years, which will give us £1,250 per year. But that is only the cost of the car. We then add our £2,000, we've got 1,250, add £2,000 running costs, that gives us £3,250 per year. That's the running cost and the cost of the car. So these are our important numbers. So the electric car is, look, £750 cheaper per year. So it means the electric car would be better than the petrol car, because it would save £750 per year, which over the total life, which is £11,250 over the 12 years. So we've got our calculations to work out price per year, an overall statement saying which one is better and why, and you could either have here £750 cheaper per year, or the £11,250 over the 12 years. Either one of those points we could use. We need to say the electric car is cheaper overall.